Hello everyone, I welcome you all in Maths by Harshit. In this video lecture, I'll discuss a previous year question of IIT-JEE Mains which came in 2023 in April first shift. So without further ado, let's get started. So what question says? First of all, I will read this. The number of elements in the set, in this set we have, okay, and what is the property of this n is 3 raised to, if we raise 3 raised to power n minus 3 is multiple of 7. Okay, so we need to find the number of elements in T. Okay, so let us assume, but what is T? T is this one. N belongs to natural number such that the value of n has to be in between 10 and 100, and one more property, 3 raised to the power n minus 3 is a multiple of 7. Okay, so we need to find how many elements are there in T. Okay, so observe here. What is the meaning of that one? 3 raised to the power n minus 3 is multiple of 7. Meaning of this one is 3 raised to the power n minus 3 is 7 times k, we can say, or not, where k belongs to integer, or we can say 3 raised to the power n is equals to the 7k plus 3 where k belongs to z. The meaning of this one is if we divide 3 raised to the power n by the 7, okay, then it leaves remainder 3 after dividing by the 7. That is the meaning. Okay, actually this complete expression relates something. Okay, this complete expression we can relate to the one important relation is congruence modulo m. Okay, congruence modulo m. So I'll discuss in depth first of all congruence modulo relation, then I will discuss this question completely by using this congruence modulo relation. Okay, so how we can use what is that one? Okay, congruence modulo relation is, suppose we have A and B belongs to Z, you have two integers, A and B belongs to Z, okay, and you have M which belongs to natural number, that is positive integer. Then A is congruent to B mod m. A is congruent to B modulo m if and only if A minus B is divisible by m. A minus B is divisible by m. Okay, or we can say, or if and only if when A divide by m, then it leaves remainder b. What it gives? It leaves remainder b. Okay, so it means that this is our remainder term. What we have? This is our remainder term. How? I'll give you example. Example is, suppose I have A equals to 12 and m is equals to let us say 5. Okay, so 12 is congruent to modulo 5, and what value I need to put here? 2, because you observe that 12 is here, 5 to the 10, and we get 2, so remainder is 2 here. First example. Second example I will take, suppose a is equals to 18 okay, and b equals b I need to find, that is remainder, and what we have, m value is m value, suppose I will take 5, you can take same, or it's your choice, 5 will take. Okay, so what we get, 18 is congruent to 3 modulo 5. Okay, it if a is equals to the 100 and modulo, what is m value? M value is I'll take 3, I'll take. Okay, so 100 is congruent to 1 modulo 3, like that we can write. Okay, now so you understand that what is our congruence modulo relation. Actually this relation is defined on the set of integers, and by this set of by this modulo relation which we define the set of integers, actually it is an equivalence relation. It is an equivalence relation, or if it is an equivalence relation, so it divides the complete set into the equivalence classes. Okay, so actually this relation is used in many purposes. Suppose we need to find the last term, unit place, second place, remainder, like remainder we are finding here na? So if we have a big digits, then we can find the remainder by these terms. Okay, by using this relation. Now I'll discuss some properties of this relation, because I need to use in this question the properties of the congruence modulo relation. So here are the properties. Here a and b belongs to z, m is positive integer. So if a is congruent to b modulo m, then b is congruent to a modulo m. What it says? It says that if a is congruent to b modulo m, if we have, then it is follows symmetric property. It follows symmetric property. And the transitive property also we have, if a is congruent to b modulo m, b is congruent to c modulo m, then a is congruent to c modulo m also. Meaning is that if a is related to b, what is the meaning of a related to b? If and only if a is congruent to b modulo m, like that we have this relation is, and b is congruent to c modulo m, then a is congruent to c modulo m also. Okay, and if a is congruent to b modulo m, then AC is congruent to BC modulo MC. Here we have this thing. Okay, AC is congruent to BC modulo MC for all c greater than 0. And if A is congruent to B modulo M, then and C is congruent to B modulo M, then addition is also A plus C is congruent to B plus D modulo M. That is addition property. And multiplication property is, if you are congruent to B modulo M, C is congruent to D modulo M, then AC is congruent to BD modulo M. Difference also we have, A minus C is congruent to B minus D modulo M. So these property you need to keep in mind. Okay. So here I'll use these properties. Okay. So first of all, some properties I need to use. Multiplication property. Okay. Multiplication property I need to use, and one more property left here. Actually, they didn't give this property, but I need to write this one. If A is congruent to B modulo M, then A raised to the power k is congruent to B raised to the power k modulo M, where k is your belongs to natural number. Okay, this property we also have. A is congruent to B modulo M, then A raised to the power k is congruent to B raised to the power k modulo M. Actually it is the same as that of the multiplication property. Okay, if we multiply, suppose I will write b modulo m. Okay, how we can prove this property? Modulo m, if you multiply both them, a square congruent to b square modulo m, again we need to multiply, so we get this one. Okay, that's why they didn't give here, but I we can, actually it is a particular case of this property, so I'll write here because I need to use this property also. I'll use this one property, multiplication property I need to use. Okay, and transitive property I need to use here. Okay, now I'll start the question. So here what it says, that they are saying that 3 raised to the power n, m value is divisible by 7. Okay, and power of 3 we need to discuss, power of 3, and restriction on n is n has to be less than, greater than equal to 10 and less than equal to the 100. This is the n value, lies in between. And now I'll start. 3, m value is here 7 and a value is here 3. I need to start. 3 is congruent to 3 mod 7, obviously. Okay, 3 square, if I raise power 3 both side, what we get here? 3 square, that is 9. 9 is congruent to 2 modulo 7. Okay, now 3 raised to the power 3 is congruent to, that is 327, is congruent to how much? 27 we have 6 modulo 7. Okay, then 3 to the power 4, that is 81. 81 if we divide by the 7, 7 minus 7, 4 modulo 7. Okay, now 3 to the power 5 is congruent to how we can find 3 to the power 5? We need to multiply both sides by the 3. So what we get? 3 4s are 12 modulo 7, and we observe that 12 is congruent to 5 mod 7. So we can use the transitive property here, and 3 to the power 5 is congruent to 5 modulo 7, because from this one relation we have 3 to the power 5 is related to 12 and 12 is related to 5, so 3 to the power 5 is related to 5, that's why. Okay, after that 3 to the power 6 is, again we need to multiply by 5, 3 here, modulo 7, and 15 is congruent to which one? 15 is congruent to 1 mod 7. So here it means that 3 to the power 6 is congruent to 1 modulo 7. Okay, now after that again 3 to the power 7 is congruent to 3 modulo 7, multiply by 3. Okay, now you observe something here. Here we need to observe something. Here if 3 raised to the power 1 we have, then we get remainder 3. Okay, here we get remainder 3. If 3 raised to the power 7 we have, then we get remainder 3. Okay, so here we observe something apart from that. What we have? 3 raised to the power 1 is congruent to 3 mod 7. 3 raised to the power 7 is congruent to 3 mod 7. Again if we are doing this thing, same thing, 3 to the power 8, 3 to the power 9, 3 to the power 10, then we get at 3 to the power 13 3 modulo 7. Okay, so here we are observing that there is a 6 gap in power of 3. 1 and 7 we have a gap of 6, then here also we have a there is a gap of 6 numbers. Okay, 8 9 10 up to so on 13. Okay, so here we get idea up to so on. Here we get idea that 3 to the power 1, 3 to the power 7, 3 raised to the power 13, 3 raised to the power 19, 3 raised to the power 25, up to so on. They all leaves remainder 3 when they are divisible divided by the 7. But you observe the 1 is not in between 10 and 100. 7 is not in between 10 and 100. So we need to start from the here. Okay. So 3 raised to the power 13, 3 raised to the power 19, 3 raised to the power 25, 3 raised to the power 25, up to so on. Like that, we have elements. Okay. Now I will collect all the powers in the set T, that is 13, 19, 25, up to so on. Now, but what will be the last term? Because I need to find the number of elements in T. So how we can find? I'll assume number of element in T we need to find number of element in T. So but observe that last term has to be less than equal to the 100. Okay, so here you can observe 13, 19, 25. Actually it is an AP. This is an AP. This is your first term. A equals to 13, first term. And what is D? Common difference is 6. So I'll assume let the last term in this finite AP is L. L less than equal to the 100. Okay. So I assume AK is less than equal to the 100. I assume this Lth term is K. Okay. Because what I need to find? I need to find the number of elements in T. Okay. So AK formula is A1 plus K minus 1 into D less than equal to the 100. So A1 is 13 plus K minus 1, D value is 6 less than equal to the 100. So here 87 we get, K minus 1 6, and what we get here? K minus 1 less than equal to the 87 divided by 6, and what we get here? 14.5, K minus 1. So K is less than equal to the 15.5. But we observe that AK, we know that na, A1, A2 up to so on, AK up to so on. This K has to be of natural number. So the largest natural number which is exactly less than 15.5 is K equal to 15. So it means that this L has to be of 15th term. This is our 15th term. Okay. So how many terms we have exactly in this set T? 15 term. So it means that number of elements in T actually 15. Here our task is complete. We can write our answer. Okay. But now we can observe, it may possible na, they will ask in exam that what is the biggest term, what is the largest term of the T. So how we can find? A15 additional, these things are additional, these things are additional. A15 is A1 plus 14D. What is A1? A1 is 13, 14 into 6. Okay. Then 13 plus 6 4 ja. And here we get 97. So A15 is 97. The 197 is the largest term of this set. Okay. It may possible they will ask that find the arithmetic mean of the smallest and the largest term of the set T. We can find easily 13 plus 97 divided by the 2. Okay. It may possible they will ask here, first question, second question, they may be asked here the arithmetic mean of smallest and largest term of largest term of AP, largest term of set T. Okay. Third is your it may possible they will ask here sum of all the terms of set T. Then how we can find S15 we can find, okay, because it is an AP. So S15 is formula what we have, the sum of first n term, n by 2 2a plus n minus 1 into d. We can apply and we get the answer here. Okay. And I think they will ask like that questions. Okay. You can generalize more this question. I hope you understand this question. If you have any doubt, then you can do comments. But first of all, before proceeding this question, you need to recall all these properties, because it may possible they will make some different question on the basis of these properties. Okay. And this congruence modulo relation is also from your textbook. So it is not of out of syllabus. So the answer is here. Answer is here 15 number of element in this set. Okay. Thank you for watching.